I wanted to give a quick example of how to divide a polynomial by a monomial. This really definitely comes in handy when we are trying to compute the function operation of f divided by g of x. And we could think of this as almost as f here in this case, and then the bottom here being g. But really we're just wanting to know, how do we simplify or divide this polynomial by this monomial, right? This one-termed item. Well, we're going to use our rules of exponents. And recall that we can always split any fraction that's written with a single denominator with numerous terms as the numerator into multiple separate fractions, or as we should start calling them, rational expressions. So I can expand my fractions out like that, and then if we have it written in this form, and this is just to really kind of illustrate what we're doing with each one of these terms when we do this division, we're going to use our exponent rule that says if you have, that should be an n, that if you have two of the same bases raised to different powers like this, where they are written as this rational expression or a fraction, the rule tells me that I need to subtract their exponents. So I'll subtract the exponent of the denominator from the numerator's exponent. So I then can rewrite all of these with my variables in one single term. I will have, and recall that anytime we have just x by itself, its exponent is 1. So I would have x to the 5th minus 1, minus 3x to the 4th minus 1, and just knowing that these are all kind of in their own little operations, right? We're only just subtracting those numbers that are with the exponent, plus 2x, and I'm going to do 3 minus 1 there, minus x squared minus 1, and recall that this last term again has the power of 1 on its exponent. So plus 3x to the 1 minus 1. So there I've now used this rule from the exponent rules to be able to simplify this expression, because when I'm done, I'm hoping I will no longer have a rational expression or a fraction, right? That is when we end up having issues with the domain, because it's possible for the bottom of this to be equal to 0. But once we do this, then this function will be defined for all real numbers. Then going ahead and cleaning up our work a little bit, let's go ahead and do these subtractions. I've got x to the 4th minus 3x cubed plus 2x squared minus x to the 1, which we could have also just written as x. And here we're going to have x to the 0 when we do this subtraction. And recall that from the 0, whenever we have any value raised to the 0 power, it is always equal to 1. So this expression here really becomes 3 times 1. So we will just have a plus 3 at the end of our expression. And now we have fully simplified it. I hope you guys are having a great day. We'll talk to you later.